videos aren't spectacular, but they're better than nothing. Make Arthur. Meg, Shane, Joey, and the two people like actually sign on all at the same time. Oh, fire. All right. How are we today on Friday? Is that where we stop? So first, if you have questions with those, you can message or give me a shout. That one might be, or if that one you could do by subtraction or division. Do the whole thing, and that's a 4 by 4 and whatever. But to get started, let's see, hopefully this isn't like 6 pages of notes. Combinations, I don't know, a couple of examples. I gotta go over here and get a, because, wait, what was that one over here? Oh, buzz off. Hey, look at that. It's got them both all at the same side. Hi. Score. I don't know what else is on that webpage. Financial, fitness, and health. Interesting. All right. Don't really need it. First off. So we've got 2 situations. 5 sprinters compete in a race. How many different ways can they medal first, second, and third? Well, we could do it with NPR where n equals 5. R equals 3 because it's better to finish first. Like that, because I don't want to bring up that calculator because it has both at the same time. If I simplify that or write it out, 5 people can finish first. Well, after the first place winner, there's only 4 left for that. And the third person can finish like so. 5 times 4 is 20. 20 times 3 is 60. So that's kind of what we looked at the day before. But what happens if it's a qualifying heat where it doesn't matter whether you finish first, second, or third? And I think apparently I forgot 3 racers. People, racers, sprinters. Three sprinters qualify for the next round. Does it matter who finishes first now? Not really. Does it matter who finishes second? Not really. Does it matter who finishes third? So what we have in this instance, we have someone who can qualify, someone who can qualify, someone who can qualify, not qualify, and not qualify. So how many ways are there to arrange those? people. Well, that's kind of like one of the repeat questions that we had yesterday. There's 5 factorial ways to arrange 5 people. But if we have 3 people qualify, whether it's Q1, 2, or 3, Q2, 1, or 3, you have the 6 ways that those people can arrange themselves in that bit. And you have 2 factorial because you can have those 2. 60, 100 divided by 3 factorial is 6. 2. There's actually 10 ways. Mark is here. Good day. 14. Joey is not here. Well, wait a sec. Eric's not here anymore. Wait. Don't try. Don't try. You're just going to hurt your brain. So there's 10 different ways. There's still 60 ways for people to finish first, second, and third. But because finishing first isn't any more advantageous than second or third, and if you watch a sprint race at like a world championship or an Olympic Games, if it's a heat and you see you're in first or second or third, if those are the 3 places that move on, they ease up. They don't care if they finish first or second. There was once years and years ago, I was watching, it was the 200 meters in, I don't know, the Olympics way back in probably the 90s. And there was a guy that was running, and if he had have ran through the finish line, he would have won a gold, or he would have set a world record. But he didn't. He just stopped. Okay, that works. As long as I know, hopefully I won't mark people absent. But I'll wait and do that on the weekend after everything's done. Oh, I've got a little box. So combinations are what these are, is an arrangement where the order of selection or finish or anything like that doesn't actually matter. So whether you finish first, second, or third. We've used the example of like selecting 3 people out of a class, and the first person gets $100, the second person gets 10, the third person gets 1. That order matters. That's a permutation. If I select 3 of you at random and give you each $10, does it matter whether you were picked first, second, or third? Not really. So that's the sort of situations we're going to look at today, and those are the sort of things that we want to think about when we have these problems. And then we're going to do probability, and that's going to come into play. And that's why I said a while ago, so for the rest of this unit, when we're talking about a situation, does order matter? Because if order matters, it's a permutation. If order doesn't matter, it's a combination. 3 students from a class of 10 are chosen to go on a trip. I'm not hearing things, am I? No. Alistair. All right. We're talking about permutations and combinations. I'll have the other notes there. So we have 10 people. So you get 3 people who get to go on a trip. Let's use T for trip. and 3 and 7 that don't get to go. Well, there's 10 factorial ways to arrange 10 people. Because if you get to go, if you're the first name, the second, or the third that gets chosen, that doesn't matter. That doesn't matter. Because whether you don't go, whether you're this person who just missed, or this person whose name got pulled left, it doesn't matter. I'm going to look at this. 10 over 7 is 10 times 9 times 8. 3 factorial is 6. This is just so I don't have to deal with a calculator. It should be 120. Now, I can do this with 10 factorial divided by bracket 3 factorial times 7 factorial. I think that's just the calculator doing everything. But to get that, I simplified this to get 10 times 9 times 8. That gets left over. But there's a function that lets us do this. Well, 7 and 3 make 10. 5 and 2, 3 and 2 make 5. There's a formula for this, just like there is for a permutation. Like that looks like 10p3 is 10 factorial over 10 minus 3, which is 7 factorial. We have this extra little bit. So combinations of n different objects take an r at a time. The only thing that's different is that bad boy. We have to divide by that extra little bit. So far, so good. So instead of doing all sorts of stuff, 16 students are in a class. And at 16, determine which way 4 students can be chosen to complete a survey. Stupid face. Yeah, no. Oh my gosh. It's Friday. I have you and one more class to do, and the other class is doing circumference. I think I can do it. R equals 4. So we can do 16, choose 4. And I'm going to write the stuff out. (16 minus 4 is 12 factorial over 4 factorial. That's a little complicated. Slow down, you lunatic. So I'm going to pull this up. Let's see if I do. Can I make this window smaller? Because I don't need everything on that window. Come on, you bozo. Hey, there we go. And this one's nifty because it shows both 16, 4. So if it was the first person got money to do it, the second person got less and all that. But if it doesn't matter, if all 4, writing, 1,820 different ways. Hopefully this is logical, that there's less ways to do things when the order doesn't matter. Because it doesn't matter if you finish first. If you're the first person to get the survey, the only advantage is you might finish first, and have time to wait, but that's not an actual real advantage. Hopefully this is okay. Oh, look at all this stuff. We got all sorts of word problems. These are all kind of traditional. The Athletic Council, and this is to clarify when we talk about males and females. They're old-fashioned math questions. It's not to say that there couldn't be other genders and that sort of thing. But what guards and forwards. We'll have to go with guards and forwards, or teachers and students, because there's no. But we're gonna do this, but I just clarify that every time because I'm not smart enough to edit things. 7-person council to look after how funds are raised for the sport. There are 15 members, 9 male, 6 female, because well, this is wrong. The committee must consist of exactly 3 females. Determine the number of ways of selecting a committee. So we have to look at males and females. So does the order in which you're selected for a committee matter? No. There's no indication or anything that, oh, the first person who gets picked gets a better job. No, they all are part of it. So we're going to do these with combinations. So if there are exactly 3 females, the R for this is 3. 7 subcommittee with 7 people. If there's 3 here, that has to be 4 because that has to add up to this 7. My wife is stealing our kids' Halloween candy. Don't worry, I got my share already. So we need to figure out that there's 9 males and 6 females on this. So this one would be 9C4. And this is 6C3. Where's my calculator? I'm just going to figure these out. And then 9, 4 is 126. C3 is going to be a lot less because there's what? I hate this mouse. 20. So there's 106 different ways, 126 different ways to choose those males. There's 20 different ways to choose those females. But we need the male part and the female part. We need males and females. So and in math means we're going to go down here and take those 2 numbers and multiply them together. 12 and 12 is 24. 2. Multiply those 2 together. So these are traditional combination questions. Well, you have committees of males or females or students and teachers. The next question says guards and forwards on a basketball team. Assuming everyone has the same ability-ish, then it doesn't matter who's chosen. Guards. You need and. And this is assuming that a guard can't play a forward and vice versa, which now in modern basketball, that is irrelevant. There's 5 guards. The starting lineup has to have 2 of them. 5C2, 1, 5. That's 10. There's 7 forwards. You'll have to pick 3 of them. For those of you who don't believe me, just 1 second. Someone's at my door. I will be right back. Hi.
This is yours.
It is?
Yeah, since that Ben's caution.
Oh,
I'm back. Is he going to the woods?
yeah, I assume so.
Is he going on? We can take him with us. We're keeping him try to see.
He's at her parents. We gave them a seat, so we did the driving.
Easy peasy. Look at that.
Oh, yeah.
Awesome. Phil.
Thanks. See you later. Hi, I'm back. Whoa, geez, I love the fact that whoever logs in first gets their picture there. That was just someone dropping off an old Halloween costume that they borrowed from Ben. 5C2 is 10. 7, 3, 35. And then we have to multiply them together, so that basketball coach has 350 possible lineups. Oh, I love this one. So if you got these two on a test, this one might be worth 1, 3. They look very similar. This one might be worth 7. I don't know, something more, because there's one key phrase. The committee wants to form for Earth Day. 13 volunteers, 8 teachers, 5 students. How many ways can the principal choose a 4-person committee that has at least 1 teacher? The important part about that is at least, because we need a 4-person committee. If it's 1 teacher, there's therefore going to be 3 students. At least 1 teacher means it also could be, or 2 teachers and 2 students. Or, less effective for a school, 3 teachers and 1 student. Or, technically, not the best, 4 teachers and not 1 student, but 0 students. So when we have a question that has that phrase in it, we have to do a whole bunch more. So for this, for the teachers, N is 8, R is 1, 2, 3, or 4. For, yeah, this is R. Oh, let's do this in a different color. That's the. So this is going to be a string of them, and or means we're going to have to add. So for the teachers, in terms of combinations, this is 8C1. In terms of this, for the next one is 8C2, or 8C3, 8C4. But it's 1 teacher and 3 students. So we're going to multiply by 5C3. This one would be 5C2. This one would be 5C1. And this one is 5C0. Blue, 8C1 is 8, and after that I don't remember them. When we get back to school, I will show you how I know some of these. 8C1 is 8. 8C2 is 28. 8C3 is 56. And 8C4 is like 170. Yeah, well, close enough. 5C0 is 1. 5C1 is 5. 5C2, I think we did that already, is 10. 5C3 is also 10. Because point at your screen there, stupid. I'm actually physically touching the screen, which you guys can't see. 3 and 2 make 5. So those are going to be equal because 5 minus 3 is 2 factorial divided by 3 factorial. 5 minus 2 is 3 and 2. So, oh, that's 80. That's 210. That's 70. 250 and 30 is 280. Which I'll double check because, again, it's Friday.
I'm sorry, 29 times 10, not 210.
Yeah, no, that's very correct. I get the hard one right. Come on, brain. Thank you. So, as I put things down and start to point at the screen again. There's 80 ways to make a committee that has 1 teacher and 3 students. There's 280 ways to make 2 and 2. There's coincidentally 280 ways to make 3 and 1, 4 and 0. So we have to add those up. Wait, well, it's 280 plus 280 plus 80 plus 70. Oh, 2 280s. 70 and 80 are 150. So there should be 2, 4, 560, 760, 2, 4, 5, 6. Yeah, that is correct. 710 possible committees. So why is that worth a little bit more? Because there's a little bit more work to be done. Why would I put one of each of those on a test? Because, well, this is a little bit more involved. This is a, hey, I have some idea what's going on. This is, I understand different scenarios. So one more thing, because we've got at least here again, is going to show 5 movies. They want to show 4 disaster movies. So this one isn't as complicated as 4 disaster, 1 horror, because they're only showing 5. It's either that or 5 disaster and 0 horror. So there's 10 disaster movies, 10C4, there's 4 horror movies, 4C1, or there's 10C5, 4C0. Well, that's 4, that's 1. I do not know what the other 2 are. $210. I don't know why I'm in a stupid face. God. What? Hard. 252. Two, 4, 6, 8, 40. So there's 1,092 different possible schedules. Now, we have to do this unit essentially to do probability because what's the probability that this or that happens? Well, if there's a whole bunch of different things, and we'll see eventually, unfortunately for some of you, playing cards is a wonderful way to do this. How many different possible hands are there in Crazy Eights? Does the order in which you get your cards in Crazy Eights matter? No. So it's a combination, and I think we talk about that a little tomorrow. Oh, look at that, boys and girls. Oh, there's the card question. But this is where the poopy part happens. We're getting towards the end. Scheiße. Gosh, they gotta figure stuff out here soon. 285 to 13. Apparently I left those. For you, this is just a different notation. This means 6C4. That means 12C6. Anyways, can 6 people be chosen? 5 free songs. How many combinations? Crazy 8. Hey, there's my question. 8. So remember, this really, I don't really do a lot of this because I show that 6C2 equals 6C4. You could do it with a calculation. I think I said the 13. Well, there's the student teacher. There's the gender discriminatory thing. Exactly. The youth hostel has 3 rooms to contain. And for each state the number of different objects. Well, there's 5 things you're picking. And that's why I know some of them, because I know if you've heard of Pascal's triangle, hopefully we're back at school soon. We can talk about that. It's kind of an application, a really nifty application of combinations. But we'll see how the union and the government deal with that this afternoon. But that would be